Hey there, I'm Alan Furstenberg,
And I'm Noble Ackerson.
and we are Two Voice Devs.
Two Voice Subs.
Good to have you back, Noble.
Glad to be back, Alan.
Last time when we were talking, we spent an awful lot of time kind of trying to build up the groundwork, trying to get up to this understanding and talk about LangChain, and we had just started talking about it, and it was getting late, so we pushed it off for today. And in the meantime, I've tried to do some reading, and I'm still feel just as lost as I was when we last chatted. Um,
Don't worry, ChatGPT 4 is also lost. And so we'll get into that.
um, so last time when we talked, we talked a little bit about zero shot calculations, a few shot calculations, which involve prompting. We then started talking about creating our own embeddings of vectors
Mhm,
and sort of
mhm,
taking documents and turning those documents into these vectors of numbers,
mhm.
which are stored in a vector database somewhere, and that's where I
You need
started
to
getting lost.
you need to index them in
Okay.
some way. Yep.
um, and how OpenAI does provide an API for these for to create these embeddings, to create these vectors
Right.
that we can then do something with. And I still have a small list of terms that I am still very lost on. But what we wanted to try to focus on today was how does that start fitting into LangChain? What is LangChain? And kind of, I guess, the bigger picture is that's great. What does LangChain do for us if we are building apps specifically around voice? Because that's like the title of this podcast.
Right. Two voice
So
steps.
that's, I think, what we want to tackle today. So maybe the first thing is, what is LangChain?
So I'll define it like they do. Um, or maybe I won't. It's basically a library to help you develop applications based on large language models in a manner that is a little bit more complex by introducing sort of workflows or variables or templates, document loading, and integrations with more than one model as a service provider. I'll call them. Um,
Okay,
OpenAI being one, and others, BERT and others being uh,
so
Hugging Face being the other. Yeah,
okay, so I think most people have heard of OpenAI. They're the
right.
people behind the GPT family. Who is Hugging Face?
Ha. Hugging Face is what I thought OpenAI would become. Hugging Face is I don't know what they call themselves, but it's basically an open source platform that brings together a couple of things. It brings together uh, community built, pre-built models from providers that have the capability of doing so and open sourcing them, language models, that is, mostly. Um, it's a community of folks that sort of take those models and expand it and sort of build on top of that in sort of a collaborative way. It has that sort of Kaggle like community to it. There's also Hugging Face Hub that to me reminds me a lot of GitHub, right? But for machine learning applications. Again, it used to be mostly just natural language applications, but lately it's sort of since grown to do way more than just text-based stuff. They do a lot of image-based stuff, so a lot of the stable diffusion related applications
Okay,
are also, yeah.
so if I'm not an AI ML developer themselves. I just want to be able to use some of these models. Does Hugging Face provide a way that I can, does it provide an API?
Yeah. Yeah. So they do a lot of that. A lot of the technologies that we use to build, large language models in the way they're sort of defined are often too large for you to sort of run locally. And if you can run them locally, Hugging Face sort of provides you interfaces and sort of guardrails to sort of run that on your local machine. And then you can use APIs into Hugging Face to sort of leverage their strengths, like their compute or their GPUs, to assist your development of a machine learning or transformer-based application. That's how I would put it. There are APIs by which you can sort of hook into it. There are even graphical user interfaces. They acquired a dashboard or front end prototyping app. It's kind of like you can sort of you build your model, you want to sort of serve it. So Hugging Face gives you a way to sort of serve your endpoints, your own endpoints, and then this interface allows you to sort of design a proof of concept or an MVP of what you're trying to do without having to worry about building your own interface. So
I don't want to go down this. I don't want to go down this rabbit hole too much further.
Yeah,
but
yeah.
I think the key takeaway for me and for this application right now boils down to, if I follow this correctly, is both OpenAI and Hugging Face give you an API, give you a library on some level that you can call to do things like create these vectors, create embeddings from it, send it a prompt and a model that you're prompting and get back results. Did I just summarize that even vaguely correctly?
You correctly, you did. The only distinction I would make is between OpenAI and Hugging Face is that OpenAI does not provide you with data sets. So they won't, you won't be able to, more than likely, you won't be able to sort of host your own data sets. But Hugging Face provides you that.
I was going to say, Hugging Face is hosting it for you, though, or can
it's hosting it for you. You can pull it down if you want, if you choose. It provides spaces for you to show your work and sort of collaborate with the community. And unlike OpenAI, the last distinction is that it also does like image stuff, like so for image and I don't believe OpenAI does. Oh, well, I guess it does.
OpenAI has DALL-E, so
right. So but like if you want to do more like object detection or sort of classical machine learning tasks with computer vision,
stuff that was state of the art a year ago.
Yeah, exactly. So Hugging Face has been around for a little bit.
Okay,
I believe they're French. Can't remember, but yeah.
Okay, so what it sounds like. So now that we've answered that, jumping back off the stack one level, so it sounds like LangChain offers a lot of different tools to access different resources. So it's got a bunch of, it's got a common abstraction level that will access a large language model. And you can say, switch from the Hugging Face model X to OpenAI Ada model or OpenAI Da Vinci model. And it kind of abstracts that away on some level.
Right.
Or I assume there are multiple vector databases. So it treats all of these vector databases in roughly the same way. So you can switch from one to the other. And it gives tools like, we know LLMs need prompts. So it gives tools to create prompts. And I believe I even saw there's like a library of prompts that are available to you through LangChain or through LangChain Hub.
Right. I've not played around with that. But yes, you're right.
Yeah. And then it provides a way to kind of hook all of these different things together so that you can create a prompt and feed it into an LLM and get a result back, or take a document in an abstract way, load that into, have something create the embeddings for it and save that in a vector database. And so these seem like common sets of things that you do. Is that the chain?
That is the chain. It is you create your own workflow, you define your own workflow, and then you're chaining different capabilities together, mostly language model related
Okay.
capabilities. And so you have LangChain.
Got it. That seems far more straightforward than I thought it was.
Right.
I guess the more that I get into it, the more I'm thinking, well, I'm as a traditional programmer, I would do things like say, I'd load the data into a document and then I'd take that document and hand it off to my embedding system. And then I'd take the results of, take that vector and save it in a database and do something else with it. I don't know why.
Right. Right.
Query against it,
I
I
think
guess.
the complexity comes in when you have to do something that maybe I want to leverage another API. So one use case that has become super apparent for LangChain, just to sort of crystallize this definition of what it's capable of doing, is the current, and I know this is not going to be the reality in the future, but currently, say, OpenAI's models that are available to us, whether it's GPT-4 or GPT-3.5 or older ones that based on what you need, sort of OpenAI claims that the training, the learned models training ended in September of 2021, I believe.
Yeah.
And so why you'd use LangChain is to then sort of leverage more current information. One of many uses that I've been focused on is how do I then sort of bridge that gap for my customers' use case and sort of leverage the strengths of this large language model that ends in September 2021, but bring it more current realities, make it more streamlined. So
It's so
it bridges the gap from capability to, if let's say I wanted to bridge the gap and bring capability, new knowledge from.
well, let's not even say new knowledge. Let's just say knowledge, because I think
Just knowledge.
I think we established last time,
Yeah.
and you've established in a number of your posts, and a number of other people have said so as well, that that GPT is not a source of truth.
Right.
It's not a source of knowledge.
Right.
So I guess that's a good question. How do we? You look like you're hedging on that one a little bit now.
It is not factually accurate and not a reliable data store.
Yes.
Yeah.
So in the sense of trying to represent something that's truth, let's kind of paint a project that we want to work on, and we'll make it voice related too. Again, so every day, it's very common, for example, for people to ask, their Alexa or their Google device, when they say good morning, they want a kind of a status report of what's going on. So, if I run a bunch of servers or something, I might, when I say good morning, I want it to tell me, hey, overnight you've got 10 million hits, one of your servers was down, here's what happened. Or we got this many hits and the average performance time is this, which is lower than usual. Could be because this broadband provider indicated they had a circuit outage. Now, as a traditional programmer, I would do things like I'd have a long laundry list of if-then conditions.
Right.
And, if, I'd have loaded in what the circuit status was overnight. And if any of them were flagged as yellow, I'd include a message saying such and such circuit was down. I'd have a report on the number of hits. But I wouldn't necessarily be able to connect all of these together. Oh, and then, you know, I'd create a script and then I'd feed it to a text to speech system to create my output. How would, with LangChain and GPT and a lot of magic, how would we do
Right.
that sort of thing?
So great question. So the chain part of LangChain will allow us to, again, like we said in the beginning, sort of combine multiple components together to make it easy for us to sort of develop
Okay.
this thing. So first, we need our domain specific data, our input, right? Input data. So we clean it up, prep it, get it ready for consumption. Traditionally, you would just go to OpenAI's endpoint or ChatGPT or whatever and say, do something with this data. Though unfortunately, if you asked, I realized last week that if you ask GPT-4 or any of the language models how, what LangChain is, it thinks it's a blockchain application.
Oh, that's a
So
good
that's,
one.
yeah, it actually sort of emphasizes the point that it's not a reliable data store. It stopped learning apparently in 2021. So we prep our data. There is a class, coincidentally, called chains in the LangChain library to help us with, question and answering, which will sort of fit the example that you brought up, which is, I initiate a conversation with my voice module and say, hello, good morning. And it should sort of get some new knowledge or fresh inputs from some magical system. So we'll get there. Now, with my data prepped, I want to then constrain my data sources to allow OpenAI to only learn I'm bringing new knowledge to OpenAI, essentially. And to do that, I'm going to actually use either the GPT-4 endpoint, whichever it is, or I traditionally like to use the ADA 002 endpoint, which will, again, like we talked about last week or in the previous episode, convert the data sources, the new data. If I'm doing an ETL from all my services, you put, they're all sort of large strings to OpenAI. That's all it is. And so we're going to be converting those strings into numerical representation and meaning using the power of OpenAI. So that's a step in a chain. So we're going this multi-step chain route. So now we're stringing together, importing our sources. This is what LangChain is really powerful at. To import this new data set, my sources, my new input source, I may, because of some constraints with OpenAI, and also maybe so that I save money. OpenAI ChatGPT-4 is very expensive. I would want to sort of chunk up the input source that I'm providing it into whatever, I can't remember the actual cap, but whatever OpenAI allows within reason. So I'm going to be chunking up those source documents or context. LangChain provides a MapReduce library, which is awesome for me for that use case. So now I've chunked it up into whatever the token cap is. And then next I need to sort of, remember we talked about embeddings, those vector representations, those numerical representations of my input data. So now we're going to go into processing. So we're talking about feature vectors. Once we process that, now my corpus of data, my input data, is now sort of a key value pair. It's actually not a key value pair. I will call the key part the embedding number, and the value being the original text. So you'll get like, the sky is blue today. You would get a massive string, comma separated, a numerical number.
So you put in this text, you get a massive set of numbers.
Right.
Okay.
So not massive set of numbers separated by commas, and right next to it, your actual source input. That so it just you can actually sort of pull it back down and sort of get an understanding of what this sentence means, and essentially you're processing. You've pre-processed. Now you're processing your embeddings and sort of changing your input data into numerical representations of it, and making it human readable.
Okay, so basically we've taken our input and turned it into the embeddings, which is basically just the sequence of tokens.
Yep.
And the tokens are represented as numbers.
Yep.
Okay, got it.
Right. Got it.
This is okay. I think this explains my confusion between an embedding and a vector.
A vector. Okay, so an embedding.
An embedding is just
called out on this. An embedding to me is just a vector. So that gets very confusing. An embedding to me is a type of vector.
So
I'm sorry, I had you like really thinking you understood it, and then I just completely pulled the pin in the.
Yeah. So what I thought we were saying at some point, somehow in here, is that an embedding of the sky is blue is it basically takes the sky is blue and breaks it up into tokens. And in this case, each token probably represents one word. So, the could be assigned 1, and sky is, 200, and is 2, and blue is 900. So now we have an embedding of 1, 200, 2, 900.
So if I were to, let me try a different way to I always sort of conflate the two. One, the vector, we learned that about vectors in math class. A vector would then be the mathematical representation of the object, right? And the embeddings are essentially doing the same thing, but more in the context of a neural network variable, right? And again, I may be getting this very wrong. To me, the output is the same thing, a numerical representation of the input that you provided, which is, an embedding of the plane banked is still a number, just like a vector is. And the vector of the plane, the vectorized representation of that embedding is where it mathematically fits in n vector space.
In n dimensional space. Okay. So what I think I just heard is the plane banked is turned into we tokenize that first. We tokenize that into a numeric reference,
right?
A simple numeric reference, but that simple numeric reference points to an n-dimensional vector.
Right.
The embedding is the simple form of that.
Right.
The vector is the n-dimensional thing. Are we on the same page?
I think that's how I understand it. The nuances between the two don't really matter to me. Maybe it should matter. For me, all I need is a numerical representation of what I'm doing so that I can sort of run a different algorithm against that to using like cosine similarity or dot product algorithm against that to see how close or how similar or dispersed to an input variable and a indexed representation of that token or whatever it is. So I haven't really truthfully gone into the nuts and bolts as to the distinction between the two.
Okay. So LangChain so far has helped us create documents with our data, chunked them up into reasonable size parts, fed this into something that will create the embeddings and the vectors for it.
I called up my OpenAI endpoint, my embeddings model endpoint, and says, hey, process this.
Right.
Okay.
Process these documents. It's given me back a bunch of embeddings and vectors.
Yes, that's where we are.
And that's where we
Now,
are. So,
without LangChain, you'd have to do this and sort of stitch it together yourself. But with LangChain now, okay, I need to persist these embeddings that have been returned, right?
okay.
You don't want to have to make a call out to OpenAI every single time the user makes a query. Or maybe you might have to.
In our example, that might not be. I mean, in our example, we need fresh data every time, perhaps. But I can easily see, or some things need fresh data and other things
some
don't.
things, right?
So okay.
Now we talk about an index database or a vector database, right? An index or a vector database of some sort.
Okay.
Well, LangChain has integrations with a couple vector databases, and ChromaDB is what I used because it was just the first library that wasn't overly complex. There's Pinecone, a very popular one. If you ever look up tutorials on YouTube, a lot of the tutorials sort of reference Pinecone. I've never used Pinecone as
Okay.
there's Elastic, good old Elasticsearch. They claim to have a vector database feature. I'm sure Amazon, like AWS Neptune or something like that. I haven't tried any of those, but I will be kicking the tires and doing a bake-off soon. But the point is, between Chroma or Pinecone or Neptune or whatever it is, LangChain allows you to integrate as long as it's open source, and assuming LangChain has implemented it into their libraries, you can make a seamless call into your ChromaDB or your Pinecone to persist the returned embeddings,
Okay.
right? Yeah.
So
And
we've got these embeddings in our database. They're indexed by the database. We now want to create our report from them.
right,
We have a bunch of data, and it's a bunch of data. It contains the status of every circuit involved in our network. It contains the status of every machine in our network. It contains how many hits, how many with the popular web pages, the performance of a bunch of other APIs. It's got a ton of data. How do we get these vectors into OpenAI to give us a summary of that data?
so we
Or
so
let me rephrase the question.
yep.
How do we now use LangChain to take this data and some AI magic somewhere and get a coherent, human understandable status report from it?
Right. So we vectorized, right?
Yep.
We converted it into numbers. We indexed, right?
Yep.
So we saved our vectors and ideally stored that content with vectors, right?
Yep.
But between that and your user interface, there has to be some logic. And this is where I'll punt it back to you is I would need to, if it's an interactive thing, let's say my voice prompt is listening for good morning, what's the update, whatever it is, or okay, Alexa, whatever it is.
We could even say that it's a batch job.
Or if let's say it's a batch job, where I would talk to OpenAI again is when I need to find, again, from the user's question, right, or the intent of what the user is looking for, to find some level of similarity between what the user is asking for specifically, or if it's just a batch job, I've sort of just injected that as a prompt that I've written with the help of LangChain and just have it the LangChain has allowed me to define the the parameters that OpenAI cares about, which are now with the GPT-4 three things: the system parameter, which is the type of conversation that you would want from the system consistently. You are a parrot that repeats whatever's in my database back to, you're not going to write that. The prompt, which means you are to, for every invocation of this service, you are to check for new information relevant to contextual and relevant to the user's question or what's coming next, right?
Okay.
Using whatever filtering and there's some rule-based stuff that happens here. And then that's a user query, essentially. You ask OpenAI for a new set of embeddings. This is going to get really confusing. A new set of embeddings to understand what the user's query is. Check with your vector database for similarity. So you're using cosine similarity or some sort of check, looking for some similarity between what the user is asking for, what the prompt wants today, and what's already indexed in your database. And the closest to it, plain banks left versus walked through the riverbank, it has some contextual and semantic understanding of the difference between the two. So it's going to always return in a level of confidence the similarity score based on the similarity score and how you spit it out.
Okay.
And so yeah.
Okay, I'm going to ignore the whether it understands or not, or whether it has semantic understanding or not. I'm ignoring that for the moment.
But that's important, right?
I think my point is more that it's not a semantic understanding. It's a statistical match in n space.
Fair.
That's fair. Not, you talk to some linguists and they would tell you this isn't understanding, but I don't want to get there. I don't want to I don't want to go there.
No. So what you just, statistical understanding sort of points me to something that is more lexical search related and more or lexical document retrieval and matching related, as you would see with full text search.
Well, no, but the difference though is that the system does not necessarily understand what the difference is between a bank where you put money, a plane is banking, and a riverbank. It doesn't necessarily know what the difference is, but it does know that bank is used in that this token bank is associated with three clusters of other words that are not related to each other. And therefore, if I say something that starts drifting towards one of these clusters, it should be responding with other words that are also in these clusters.
The problem is in real life, like that you've just described a great lexical search application. What I've observed, it's doing some other things. And so again, you've got this world's knowledge, just billions of parameters that it's trained on. And so it's not, I don't want to anthropomorphize a large language model in the way that you're arguing to say it understands the difference between bank and bank and bank, or Paris and Paris and Paris. Paris Hilton, a named entity being a person, Paris, Texas versus Paris, France. However, I believe OpenAI is including, I'll call it metadata. I may get this wrong, but it's just metadata, which is also an embedding appended to your whatever it returns with, of in the context of this query, this person is actually looking for something that, again, it's not 3 dimensions. It's
N
God knows.
dimensions, right?
Yeah, right. And so, yeah, so it's saying that return similarity based on these 2 vectors, such that it isn't just the most probable closeness, but most similar and most likely to be relevant to the context of this conversation as well. Did I say that well?
No, I get what you're saying. I think though, if again, from my conversations with linguists, and I'm not sure I understand what they're saying correctly either, the way that these models are judging understanding or
Right.
contextual understanding is different than how humans think of contextual understanding. The models are thinking of contextual similarity, i.e., they are
Yeah.
close to each other. They are close to something in n-dimensional space,
Mm-hmm.
and that's not how
Mm-hmm.
humans think of it.
Yeah, I'm not. I'm. This is way above my, like, when it start. We're venturing in neuroscience, right?
Well,
Like,
now we're also venturing into n-dimensional math,
right,
which
right,
so I can kind of understand this in terms of n-dimensional math.
right,
That
right,
for a single token, it may in its vector may be mostly empty, yet for individual places in it represents where it has overlap in these mysterious parameters that it has somehow figured out it belongs in this particular space, and that on some level some things start to collide and be close to each other, and that's the matching that happens. Anyway, skipping back to where what actually happens here. So what happens when we issue a query to ChatGPT or to GPT, it's returning another embedding.
Yes, it's doing the
And
same thing again. Yeah.
it's returning an embedding, and it is our vector database that says what is the closest thing in our database to this set of embeddings.
Correct. And then we return from the deck vector database, return the what they call a top K, most relevant vectors that we've already indexed. The next step from that is you strip it of the numerical representations of it and just return the value, right? Like I keep calling it key value pair, but really isn't. But the value
The,
of that numerical representation. So
re,
it's human readable and
I was going to say
understandable.
returning the human representation of that token.
Exactly. So that's you got it. You got it. Yeah.
It's kind of amazing to me that this is returning any coherent output at all.
And it does consistently.
Well, and I guess that's what the magic of the transformer is that it doesn't just return one token. Is that it kind of, well, okay, I guess that's it. Is that
That's what I was trying to say. It might be. I was sort of calling it metadata that
well,
represents too.
well, I think I'm beginning to understand what's happening now. So we get back a set of tokens, and what the transformer system then does is says, okay, based on all of these tokens so far, what's the next most likely token based
Yep.
on our n-dimensional vector database? What's the next most likely token? And then what's the next one after that? And after that, and after that,
Note
and
that
so
we
forth.
did that in the beginning too, when when we were going through. So remember, we've gone through for this fictional voice application. We went through 3 steps: the initial vectorizing, or like
Right.
converting or thing with the embeddings at model endpoint, the index part, so persisting that whatever OpenAI returned, and then we'll call the third one search, right, where the user query, which is essentially just a hard-coded prompt within LangChain in the case of this example, is going back and doing what we did in the vector part essentially again, meaning we're using that
Right.
new user query, which is always in this. fictional example going to be the same, but we're just checking back with OpenAI, bringing it back to the vector database and our index. So there's a couple things that I've glossed over. These vector databases aren't just persistent layers, right? Like they allow us to index, they allow us to sort of filter. There's a lot going in there. There's LangChain also, and I'm gonna probably get this wrong, but LangChain I believe also allows us to do some things like sort of splitting. We talked about caching it. Well, it's basically just the conduit between your local environment and the library that it's sort of like a wrapper for the library that you really need. And so in this case, you would go back to OpenAI and say, hey, there's a import that I use called TikToken that allows us to just split my text and sort of process it in a way that it's not expensive. So the eagle-eyed listener or the listener here is probably wondering, it's like, this gets super expensive if you're doing this over time, even if it's just batch job and all that stuff. And so LangChain is also allowing you to do some optimization of your entire workflow to make sure that you're not, getting a ridiculous bill at the end of.
Okay, so it's got a caching. Okay.
Yeah. I just had to mention that before we glossed over that.
I'll be honest. Every time I think I have this in my grasp, it slips out again. I guess it really starts boiling down to understanding. Oh, and then I guess is the final step of all of this is we now have a result, and LangChain lets us call an API that we create.
You would use your Google TTS API, whatever it's called, the GCP one, or your Lex or whatever it is, and then convert that audio the text representation into audio and then play it back to the user. Yeah, I think
and LangChain lets us do that because it's open and lets us just write any old plug in any API as long as we can get it into a RESTful
API.
Yeah,
exactly.
Okay, so I can see. I mean, LangChain really does feel like kind of just this Swiss Army knife where you keep pulling stuff out and it just all works together because it's meant to all work together.
You know what it is? It's Ansible Tower. Are you familiar with Ansible?
No.
So LangChain is not novel in any way in how it's trying to do this. It's just sort of special purpose for language models. And
I mean, when I first started reading about it, it's like, doing LLMs in a composable way. And I'm like, and what does composable mean? Am I supposed to, where was this term? And when I went and looked up what composable was, it's literally just being able to string together things in a way with predefined function calls. And I'm like, that seems really straightforward.
Back in the day when I first got into technology, I wasn't a programmer. I was a systems administrator. And we would use a tool called Ansible that had its own pre-built playbooks. So you didn't have to code if you want to. But it was a sequence of like tasks and commands that you would sort of string together. Configure it. You wanted to configure a network or upon authentication, we have to trigger a scan, and just a handshake to make sure that they are who they say they are, send that to this thing. Oh, wait, there's a Windows update waiting, trigger this other task, and then just sort of chain, pun intended, chain all of those different systems together. And it was a graphical user interface that made life a whole lot easier. So what's old is new again. And Ansible is one of many tools like that.
What this actually reminds me of, and I can easily picture this sort of thing being built, is, if you're familiar with something like Scratch.
Oh, yeah. My daughter
uses
that all.
Right. Yeah. It's block-based programming. You drag a block over, and then you drag another block over, and if it's not meant to work together, you can't plug it in. You drag a block over, and if it needs some other components to it, you drag those things over and where they plug into the side. and maybe you'll enter some things in to define details. So I can easily see LangChain being the underpinning, if it hasn't already been done, for a visual programming model.
I'll do you one better. I love that analogy, so I'll do you one better. Where I think this is going to be a bold assertion without any facts or data, but where I
Don't worry,
think
just it's just between us, Noble. You know, nobody
I
watches
know
this show.
where I think things are going, it's not just going to be visual. And yes, you're right. They should probably consider sort of a canvas so that you can sort of just visualize your chains, and that would be a brilliant feature. It's probably coming as a paid feature or something. Um, but this new world of natural language understanding or model as a service or
Ooh,
generative AI means that we're actually programming with language.
yes.
Where it's graphical is an additive plus if you like to operate that way. But rather than in code, we're giving it, LangChain is allowing us to string together natural language in the way that these model as a service systems understand. So it's Cohere or OpenAI or
And
whoever.
and this starts getting incredibly meta, so that
Yeah,
you're going to be using a a chain
right.
to take your voice and build another chain and run it
Which
and
is
test it
the,
and so forth.
by the way, and you'll notice very quick once you enter this new world that what you just said is incredibly powerful once you harness it. I've been in situations where I have dual monitor setup. I've got ChatGPT on one side of my setup, and I've got my Visual Studio Code, and I've got the LangChain docs. And I'm almost using either the OpenAI Playground or ChatGPT interface as the a rapid sort of test to see, like just to, or I might even ask ChatGPT, give me a better prompt for this. So
Uh-huh.
it's like meta to the nth value. It's like you're feeding the system something that you want to achieve, and it's spitting out something that you can plug into LangChain, which in itself is sort of that abstract level of abstract. So this is why that gets so
This
confusing.
yeah, there are things about this that are starting to make me nervous again. But I think we're going to leave it here because we've been talking for a while.
In
And
circles in some cases.
and I, like I said, you know, I feel like I have it in my grasp again for the moment, and it's going to slip out, I'm sure. But I feel like I
If
have it in my grasp at the moment.
and until because you're bringing, and this has been a great cathartic almost conversation with me because it's sort of challenging what I think I know in a way that things that I've just sort of just brushed under the rug, like what's the difference between a vector and an embedding? It's like, I don't care. Does it do what I need it to do?
Well,
But
yeah,
I love this conversation. But if I were to sort of sum it up to leave the audience with something cohesive, or at least in the best way that I can, is you've got this powerful library, LangChain, that in its attempts to simplify the steps within a workflow to get your visual your audible update with our fictional example in some cases has made it way more complex than it needs to be, but in the spirit of allowing you to templatize the prompts that you will be providing it, chain that with an API, a model as a service API that allows you to vectorize it or return something from one of these large language models. Allow you to talk to a completely different API or any API
bring
as
all
long
of
as it's
these things together. Yeah.
yeah, bring all this in the API example that we use. We needed an index. We could do that. We could have done some calculations by talking to Wolfram. used Google search API if we wanted to get some relevant current thing. Is there a Google News API? I don't know. So, and then sort of that front end, or at least the interface with the user, allow us to sort of find similarity between, again, it's just that Ansible like glue, or the
Being
Scratch
able to
like
piece things together.
glue to sort of piece it all together in the spirit of making things simpler. When I've kicked the tire, I got early access to GPT-4 and I tried to do that. I failed miserably. And that was because it just makes, it's just unnecessarily complex once you start getting into it. So once you start, understanding it a little bit more and simplifying it, I'm sure it makes it easier. You don't have to use everything by the book like LangChain presents it to you. You can sort of do whatever makes sense
Well,
for your
I
use.
think that's it, is that LangChain gives you a bunch of tools that are abstract tools, and you need to start understanding those pieces together. So,
Right.
I'd love to hear what people are doing with LangChain, the pieces of LangChain that people find most useful, or, you know, need more attention or whatever. Um, Noble, where's the best place for people to reach out to you if they want to chat?
Yeah, Twitter. And that would be at Noble Ackerson, Nobleackerson. Um, and from that, I'll just leave it there. That hub is connected to my YouTube. It's connected to my Medium, where I write a lot about this stuff. It's connected to other, my LinkedIn maybe as well. But I'm pretty easy to find, as I
Okay.
mentioned.
So fantastic. I can, and I am quite sure, as I keep going through this, I'm going to be pestering you more with questions as well.
It's
Um,
great. Yeah,
and
please do. Yeah. And
so
anyone listening or watching, please ping me as well. Because as we go through this is all new, right? LangChain has been alive for how many months
a
now?
few months now, yeah.
Yeah, exactly. So we learn together. Just I'm actually very curious as to what questions you might have for me in the future.
So and I'm sure we will also be talking about them in future episodes of Two Voice Devs.
Two voice devs. Thank you so much for having me, Alan.
Oh, thank you for coming on, Noble. This has been great.